major community types. There's several. We also have wet meadow, but there's no wet meadow in this transect. But here we have the first section. You can see where this is dry heath, and then it drops down at the end. There's a section in the middle which runs between, you can see there's a rebar out there that's just past the transect. That rebar and that rebar, it runs along the shrubby area, and then past that rebar to the end of the transect, it's the moist acidic tundra, so that's the tussock tundra. And so what we're doing is we're covering the three of the major community types here. And so we do this on a daily basis, and we're monitoring phenology through reflectance. So on the tram, we have a CNR4 net radiometer, which does albedo, like a level of reflectivity. So like snow is very reflective, so it has a high albedo, whereas a dark material or a darker color like plants as they green up are going to have a lower albedo. We also have an apogee, which is a thermal camera or a thermal IR thermometer. So what it's doing is it's giving us the average surface temperature of each section of the transect as it moves along. We also have a Maxbotics sonic distance sensor, which tells us how high we are off the ground. So we can monitor how much of a footprint our instrumentation has on the landscape, but also it tells us we can look at canopy height changes. We also have a JAZ spectroradiometer, or a spectrometer, and so what that does is it monitors from 300 to 1100 nanometers, so it does visible light and then also some near infrared, and that allows us to monitor the greening of the tundra as the season progresses. We also have a green seeker, which only does NDVI, but that allows us to monitor also the greening of the tundra over time. And then we have a FLIR, so a forward-looking infrared camera, which is giving us a thermal map. It's taking images that each pixel is calibrated to a temperature, so we can look at temperature changes.